Hello, my name is Lida Lungsha Anak Gerontang with metric number 84376. In this video, I will share about our projects that will be constructed in the Kampung Endap Samarahan. The purpose of this project is to provide a detailed rough foundations, design calculations for a multi-purpose hall that is to be constructed in the Kampung Endap Samarahan. The objective of this project is to design a safe and cost-efficient rough foundation to address the challenge posed by the site soft soil conditions. And for the site condition, the soil bearing capacity is 65 kilonewton per meter cube. And for subsurface is soft to medium clay underlain at 10 meter depth. And for design scope, we need to calculate the soil pressure to ensure the foundation safety. Next, in this slide, we can see the details of column and load, include the load factors. Okay, for example, the column for A1 is the load is 550 kilonewtons and the B1 is 1200 kilonewton, and until D3, which is 500 kilonewton. So the first step to start the design calculation is to identify the length and width of the multi-purpose hole to know the area of the project. In these slides, we can see that the soil pressure is to be calculated at each point of column, where in this case point A1, A2, A3, B1, B2, B3, C1, C2, C3, and D1, D2, and D3. So, the soil pressure can be calculated using the equation where Q is the total of loads from column, My and Mx is Q times by E. Ly and Lx is the moment of the inertia. Next step is the value of E can be determined using the formula Ey equal to y prime minus L over 2. And Ex equal to x prime minus b over 2. X prime and y prime can be determined using this formula. X prime equal to q1 x1 prime plus q2 x2 prime plus q3 x3 prime over q. For y prime, we can use the formula y prime equal to q1 times y1 prime plus q2 y2 prime plus q3 y3 prime and over q. Next step is, after the soil pressure is determined, the raft is then divided into strips such as strip A1 A4 D4 D1, strip A4 A5 D5 D4, and strip A5 A3 D5 and D3. We can see in this slide. Then, for each strip, the average soil pressure, average load, modified average soil pressure, and the column load modified factor. After each column load has been multiplied by the modified factor, the shear force and bending diagram is to be constructed. Then, from the bending diagram, the biggest positive and negative moment is taken and its magnitude is calculated. After that, the area of reinforcement is calculated using this equation in the slide from equation 8.36, which A value is calculated using the formula A equal to AS Fy over 0.85 Fc prime times by B.
Hello, my name is Edra Isaac Anagunto, matrix number 83062. And the next part is for the result. The soil pressure at A1 is 74.77 and at A2 67.97. The soil pressure at point A3 is 61.17. At D3, the soil pressure is 48.37, D2 55.16, and D1 61.96. After the raft is divided into 3 strips, the first strip, which is A1, A4, D4, and D1, the average soil pressure is 68.37, and the column load factor for strip 1 is 1.03. Hence, the load per unit length of the beam is 199.78. The first load at strip A1, A4, D4, D1, first load is 565.1. The second load is 1232.95, and so is the load 3, and load 4 is 565.1. After the factored column load is calculated, the SFD and BMD is constructed, and the result is, for the maximum positive moment, which is from strip number 2, the maximum positive moment is 5181.26 kilonewton meter, and the negative maximum moment is from strip number 1, which is negative 1036.81 kilonewton meter. Then, using the maximum positive moment, the area of steel reinforcement is calculated using the equation mu equal to phi times as times fy times d minus a over 2. As you can see, the value of a is 23.51 as. Hence, the as is equal to 0.0425 a. And then from the maximum moment, the a value is 0.0976 meter. The area of reinforcement is 4148.7 mm square per meter. So for the maximum moment, the 20 millimeter diameter bars at 75 millimeter center to center is used, as the as is equal to 4189 millimeter square per meter.
To conclude this project, we have learned to value how difficult the design process is and how it calls for both technicals and inventiveness to solve challenging engineering challenges. And from the addition to cross-checking figures, my team is cooperative efforts demonstrate how crucial communications and teamwork are to produce the strong final design. So last but not least, this design project has improved my knowledge of rough foundations and the reinforced concrete buildings and how they are used in practical situations. The necessity of ongoing education has also been underlined, since every project offers fresh chance for development and challenges. Last but not least, and here is our meeting log, and hopefully this project will be successful. Thank you.